Hello, hi. My name is Flavio Fernandez. I work at Red Hat, and specifically, I work on the SDN group for the OpenDaylight project. When I was doing when I was working in Helium with a couple of Red Hat folks, we did the L3 forwarding feature. I was asked to make a little video on it to give it a demo and basically a tutorial and a walkthrough just to point out the main features and how it works. So without further ado, let me just get started on that. I'm going to start by sharing my screen here. That's it. And I will be talking while I'm playing with it. So for starters, to do the L3 forwarding, you need basically OpenDaylight, of course, Helium. The latest Helium is mandatory because there's been bugs that we fixed ever since Helium released that you're going to need. You need a hypervisor, of course, and I use Vagrant to stamp out the OpenStack nodes. So with those three pieces, you can just get started. So I created a directory called demo. Right now, I just have, which I'll talk about in a minute, and I will grab the latest and greatest Helium build. Actually, the build for Helium SR1. So we do that here. I'll make this a little bigger, actually. And okay, probably should have done this before I began this broadcast. All right, so while it's doing that, I will go ahead and unzip it. There we go. So I just do unzip and I pipe that to dev null so it's not too chatty on the screen here. Okay, so now that I'm here, I go to the distribution directory that I just created, and I need to do one piece. So normally the L3 forwarding feature is disabled in Helium. What you need to do is to edit a file. In that file, and I'll have a link for all this later, is etc custom.properties. So in here, if you search for L3 forwarding, you see that's the commented out. You just uncomment the line, save it, and you are actually ready to start OpenDaylight. This Helium release is in the carafe, so you basically do bin carafe, and once you're there, what you want to do is install these features. Basically, these are the features that would enable OVSDB, the northbound interface, as well as the northbound interface for Neutron. And with that, we are good, except for one thing. So there's an outstanding bug that makes the log very chatty when you're doing this test. So I'm going to go ahead and disable that log, actually set the severity of the log to error level instead of warnings. And we'll do that once I get the prompt here. Okay, so this would be the log that I'm referring to, and that's the bug, by the way, which I'm actually working on that, and I'm just currently getting reviewed. The other log that, just to make things interesting, is this log. That's the Neutron L3 adapter. That's the place, and I'll walk the code towards the end of this broadcast, that actually does the funneling, for the lack of a better word, of all the L3 events, all the Neutron events coming in and taking action with the L3 programming and all that. And with that, I think we are all set here. I'm just going to do log tail so we can keep seeing the log on the screen. Now, the next thing we're going to do is getting OpenStack. Now, for OpenStack, we require some changes, not changes, but we require a Neutron plugin, a Neutron driver, actually. And Dave Tucker, a buddy of mine who worked with me on this project, actually worked on that piece. And I'm just gonna go here, demo. What you want to do is actually clone this project, which actually I have it open on a page here, this Neutron driver page. So what this does pretty much does a couple of things. First, it provides a Vagrant file, which is what we're gonna need to stamp out the nodes. The second thing it does, it installs an ODL driver in the Neutron, basically to tell Neutron that there is an L3 driver, and all the routing events that we get, instead of going to what you'd see an L3 agent, would go to OpenDaylight. So these are the events in there, and I'm not going to go into details in that, mostly because I don't even understand them very well, you know. But this is the piece that to take care of it. Now, I'm going to go and do a little bit of jumping around, so while I'm talking, I can get the stack going. So to do that, we would do a git clone of this GitHub repository. I already done that, but if you were to clone, right, you would just done something like this, and I'll do it here, right, and have ODL Neutron drivers here. Point out a couple interesting things here in the Neutron drivers, but while I'm doing that, I'm gonna go ahead and kick off stack just to save us a little time. So for that, I'm gonna go here, 1 second. Yep, is that right? Yeah, just do this. Up. Okay. Okay. So here, drivers, and first thing I want to do, which is to show you, is when you start, is that right? Yeah, that's right. Once you start Neutron, a Vagrant up, yeah, just to get my VMs going. Once I start the Neutron piece, we will normally create some networks, the initial network that Neutron does by default, and I neuter that just to keep things from getting confusing on the screen when we come up. Anyway, so what I have here basically is this. I'm using Vagrant. I'm stamping out 3 VMs, and gonna have OpenDaylight. We actually have OpenDaylight running in my laptop already, and these 3 will use, because of the local config, which I will show right now, it will use the OpenDaylight from the Vagrant file. So let's get on the Vagrant side of things. Copy this link here real quick. All right. And I took a snapshot of this so you can visualize it. So yeah, first thing you're gonna notice is you need to tell Vagrant which IP addresses you're gonna use. I already have these configured, but basically that's the IP address of the control node. And for all the compute nodes, you can have I think up to 3 compute nodes in this environment. These will be the base address for them. Another thing that might be interesting mentioning is this hosts file, which is here. if I go to the driver, yeah. Okay. Yep. Puppet template host.erb. So this is basically what builds the hosts in there, and we also create a file, a JSON file up on this directory called here data, yeah, that contains that information that I was just talking about. Okay, now that my VMs are up, Vagrant status. Yep, see I have 3 there, and the reason I have 3, I have that is because I needed to export a variable called devstack num compute nodes. So if I do env grep devstack, see this is it's telling Vagrant this is how many compute nodes I want. Okay, so now that I'm there, I can do a Vagrant SSH into the control node and cd devstack. I wanted to show you one change that I did. Is I commented out the create initial network part of Neutron. And one other probably very interesting piece is the local conf. So this is because of Vagrant and the installation, and there are templates. And actually, let me just jump in there real quick. If you go to here, see these are the templates that the Puppet used. And what's probably very interesting to point out is the IPs, right? They're all dynamically filled in from Puppet as Vagrant. Vagrant uses Puppet as a provider in this case. Another very interesting thing is the fact that we use this ODL driver for the ML2 plugin. And this hosts OpenDaylight address, which comes from that JSON file. Besides that, this piece is also interesting, which is we're telling Neutron that we're using the null driver for the Linux interface. In other words, we're telling Neutron, don't do any IP stack forwarding. Let ODL deal with that. So those are what I was gonna say. Now we have ODL going, and we have devstack here. So I think I'm pretty much ready to just go ahead and do a stack on the control. This will take a few minutes. And let's see what else. Oh yeah, I think it might be interesting while I'm here to show this file, which is the L3 ODL. So if you go here and you go to ODL drivers L3, the L3 ODL.py is the piece that actually is taking the events from Neutron and conveying it to OpenDaylight. So it's really doing this client send JSON, and it's using the northbound interface from OpenDaylight, which you actually see it in here in the local file. Here, if you go to Puppet, here, nope, not there. Templates. You see it right here. See that's the URL, or the entry point URL for the northbound interfacing to OpenDaylight that gets exercised by the Neutron events. So once I get this guy stacked, actually I'm gonna go ahead and start the other guys is stack as well. Stack, and Oops, SH. All right. So while that's happening, this is what we are going to do. I am going to put 3 VMs, and I am going to use, I'm going to, with ODL, I'm going to create something that looks like this. So VMs 1 and 2 would be, they're all in different, they're in their own nodes. They don't have to be, they can be together or separately. But they will be associated with a subnet, you know, a network and a subnet that are separated that way. And in order for packets to cross from here to there, we're going to some OpenFlow rules that actually pretends there's a router. So this router actually it doesn't really exist. It's just a fictitious router that deals with the forwarding, the L3 forwarding, basically for routing, and the ARP management. So when hosts are ARPing for either each other or for the router, they get an answer. And I will definitely show you the rules that go with that and how the tables in OpenDaylight work for that. One other piece of information that might be interesting is that these guys, yeah, they are completely agnostic that OpenDaylight is doing the forwarding. As far as they're concerned, they're just going through, you know, the usual OpenStack tunnels and and connecting as if they were, you know, just on their own in the real world. Okay, so we get still stacking here. Okay, I got 2 compute nodes stacked, but the control is still chugging away. So give it a little more time here. And what else can I talk about that is probably relevant here? Right, so I was mentioning all the forwarding actually happens through OpenFlow rules. So we need a somewhat new OVS to support these things. I think you need at least version 2.1. With the Vagrant install that we did, we actually not only install a VM, but also pull in the latest and greatest OVS, which happens as part of the installation right here. In the base class, if you look at it, we pull in Open vSwitch and install it. Okay, so are we there yet? All right, looks like we are almost there. We're seeing some events here on the OpenDaylight side. Okay, yep. All right, cool. So what I can do at this point is actually fire up Safari, and we can look at the Horizon GUI. Right now, there are no instances or anything. It's not all that much to see here, but just log in here. All right, so now this part is the part where we would actually go ahead and start creating things in Neutron. So the first thing is I'm going to paste a couple of commands here, and then so this is just setting up the admin and creating a SSH key. The second part would be creating a network, and this, and also we're going to create a subnet that goes on that network. And for this demo, I'm using 10/16. And you see the gateway 10.0.0.1 is the IP address that the router got. All right, so I'm going to go ahead and create another network and subnet. In this case, will be at 20. This is very fictitious. That's why I took the liberty of using 20. I know that's normally a not okay value to use. And now I'm going to go ahead and create a router. and then I am attaching interfaces to the router to these two subnets that I created. Okay, so at this point, if I go here and I do an OVS, we're gonna see that we have the bridges, and we don't actually use the BREX at all. The whole magic call happens within BRInt. And if I look at the ports, let's have that. And you see there are no tunnels yet created between the nodes because there wasn't a need to have one yet until I created a tenant. So this is probably a good time for me to go ahead and create that very first tenant on the control node. And I start seeing some events here. First thing you see is because the tenant happened, we're now programming ARPs and forwarding flows into the into the node. So if I do dump ports, now we're gonna see that we have two GRE ports. See, this is so it'll be 20, 21, 22. So in order for 20 to get to 21, it's gonna use this port, and it's same for 2. And now you're gonna see two tap interfaces. See, port 1 and port 2. Now, it's actually easier to look at these guys and make this a little bigger. Is if I do a dump flows, this is gonna get into the part that gets kind of fun. First thing you're gonna notice is I have port 1 and port 2, and I can easily tell the port 1 went to this address here. And why is that here? Here, if you look at this rule, port 1, that MAC, and that MAC B1DD is what we can see here. B1DD is 10.0.0.3. So I can tell already that something was given the address 10.0.0.3, and I'm gonna go through this table in a minute, so just hold on. But I know that port 1 goes to 10.0.0.3, and port 2 goes to BB77, which is this guy here, 10.0.2. Now what this is, even though I just created one tenant, we also created a DHCP server, and that is also a Neutron is given an address. So if I went back here, we can see now, if I have a look at instances, we see that the host 1 was given the address 10.0.0.2. So I know that this is the MAC address, and we can get into it in a minute. And we know that 10.0.0.3 is the DHCP. Now let's look at this table real quickly. The first thing we're gonna see is table 0. So this is what they call the pipelining and it's kind of new in Helium for OpenDaylight, OVSDB. Table 0 is what we call a classifier. I don't want to dwell into this too much, but basically what you get here is a couple of breadcrumbs. The first thing is we know that port 1, if something came in port 1, you better have that MAC, and if it doesn't, then we're gonna drop it. That's what these two rules are. So if you look at this line and then look at this line, it's like we better come in with this MAC or it will get dropped. The second thing we do, which is kind of interesting, we load in the register 0. We load in value 1 into it, and register 0 here is kind of very important because it determines how we're gonna broadcast packets down on at the bottom here at the end. So that's basically table 0. And we know that port 1 goes to this guy, and that is this guy here, 10.0.0.3. And 10.0.0.0, so there'll be the DHCP, and the 10.0.0.2, as you can see here, is that the host we just created. Table 20 is very interesting table. So because we are pretending to be a router, we need to deal with MACs and ARP tables, and what we're gonna do here is just kind of a convoluted rule, but basically we are looking at ARP packets, and we not only look at the ARP IP address, but also the tunnel ID, which translates into the VLAN. So 0, you know that 0x22b is the VLAN for NAT1. And when we get that, we create a rule that basically makes an ARP answer, you know. So we basically take values and we craft a packet that looks exactly like an ARP answer, and then we call this action on import, basically send a packet back where it came from, and we are done. So that's really like a pretty powerful and a crucial piece of doing L3 forwarding that we needed to do for Helium. The second thing we do is table 60. So let's not worry about table 40 for now. Table 60. That's the part one. We do routing into what I call it 2 parts. On table 60, we are basically doing the routing piece of things. So when you're going from one subnet to another, you need to basically replace the layer 2 of the packet. And in here, that's exactly what we're doing. First of all, we are decreasing TTL. That's one of the actions. We are setting the VLAN. So basically, you're crossing VLAN. So in this particular rule, right, you're going from VLAN to C to VLAN to B. So you're going from 10. You're going from 20 to 10. And if you look at it, this is pretty much the inverse of it. We're going from to B to C. And another thing we do is we replace the source MAC address. So this is the MAC address of the router, right? So that's the piece, what I refer to as first half of the routing exercise. The second half is actually a host-driven table 70. And what we're doing here is we are explicitly looking for that IP address, and then setting the destination MAC to where it belongs. So in this case, we know that 10.0.02 is for a device that has this MAC in it. Conversely, you know, and the same thing for 10.0.03. And last table is the table 110, and that's the one that we're actually doing the layer 2 forwarding. So if you, let's say, 3 feature, table 110 is always there. And in here, we are basically doing the final piece of the forwarding. At this point, we're not really changing anything in the packet. We're just looking at the MAC DA and sending out of the right port. Because everything here is within this node, all the outputs are 1 and 2, but you're going to see later, I'm going to add a host on a different node. You're going to see changes in this table. And another piece, last piece here in 110 is what I was referring to as a broadcast. So if you have a packet that's either multicast or broadcast, that's basically what this is, on a particular VLAN, then the way you flood it is dependent on this register 1 and register 0. Register 1 means this packet was generated internally, so not only flooded to the other members of that subnet, but also to the GRE ports. So if I go back here and you look at the ports, see that ports 4 and ports 3. These are the ports that we use to get out to the adjacent nodes. And that's why we flood. There's 2 variants of flooding. There's the flooding within, the node, and not only within the node, but to all the other nodes. And that's basically table 110. So now that you've seen that, I'm going to go ahead and create the second tenant, the tenant that would live on the first compute node. And I'll do it right here. There. All right, so now if we go back to that table, the flow table, things get a little more interesting. It's still not all, completely interesting because we're not really routing across. We're not going from one subnet to the other. We don't have any hosts on the 20 yet, even though now we have a rule that tells us to go there if we need to. But basically, what you see here now is 10.0.0.4, which is going to be the new host. We can reply to ARPs for it. So now this is the other part that's kind of interesting. We actually, as a side bonus of this feature, we have what we call a distributed ARP. We ARP respond right within the node, even though the tenant, the VM that we ARPing for may not be in that node. So you basically save a boatload of broadcast storms by catching these ARPs right where they came in and responding on behalf of whoever it is. So in this picture here, when VM1 is ARPing for VM2, and they do ARP for each other because they're in the same broadcast domain, this node here, this OVS, is going to take that packet and reply on behalf of VM2, and the ARP broadcast never actually leaves the wire. And the bandwidth between nodes is a very precious thing. So doing that, you can save a lot of traffic in a data center. And everything else basically is unchanged here. Let me go to the compute node now that we just put the node there. And if I do a dump flow there, you basically see the same thing. Oh, there's another interesting piece. You see these IP addresses? These are IP addresses not only for VMs in this node, but all the other VMs. So here, when we are doing a route and we are going to 10.0.0.2, and we know that 10.0.0.2 is not on the compute node, it's on the control node, we actually, first of all, we translate the MAC to be the proper MAC, right? BB77 in this case. And then if you look here, BB77, there's on table 110, there's actually a rule here that says, okay, if you're going there, go out port 1. Now, port 1 in this guy better be the GRE port. And sure it is, right? So this is a port on this guy, the compute node, that tells me, okay, if you want to get to this node, you better use port 1. And that's why there are rules here that says, okay, if you're going to either one of these two, use port 1. And that's just straight out layer 2 forwarding, nothing to do with layer 3 really, but it just goes very nicely together. Now, I haven't created anything on this node yet. This is the compute node 2. So if I do a dump flow here, it's very boring. All these funny and all this fancy ARP stuff that we have on the other two, it's still not here because we don't really need it. What we do have is this. Now, you may ask, what the heck is this doing here? Well, this is because if you are going from one, if you're doing layer 2 forwarding, you still need this. You still need to know that if something came from this VLAN, it needs to go out of the other VLAN. So that's what this is here for. And we have the max not only for the nodes here, but that now here see port 1 and 2, and this must be the 2 GRE ports in this guy because there's really nothing else in this guy. So just have GRE 1 and 2, port 2 and 1. So he knows that if he needs to go to this MAC, go out left. If you need to go to these two, go right. All right. So, okay. So now let's go ahead and create this final tenant here. Go back to the control node. And I'm creating the tenant on that, the final place. And if we go here, first of all, we're going to see more ports, right? We're going to see a new tap port here for that instance we just created. And we're going to see a whole lot of new rules that weren't here before, right? Yeah, so we have the ARPs. And once again, we're doing ARPs on behalf of the other one on all the subnets. In this case, we don't have any attachments to the 10 network. That's why we don't reply to ARPs on 10 on this particular place. But we do know how to route to them all, right? So even though 10 network is not here, we do need to know that in order to get to this host and to this subnet, we need to to the proper things. And that's that for rules. I don't know if there's something else interesting here that I can look at. Let's see. I guess I can just, yeah, one thing I wanted to do is show you the fact we really are just using the int, the BR int. We don't have fancy bridges or anything. All the magic is happening within rules and within the tunnel IDs. So yeah, these are the two subnets, still nets, and that's how we keep things separated. Should we have another tenant that has the same IPs and all that, it doesn't matter, because all these rules are very specific to the tenant and the VLANs on that tenant with these tunnel IDs. All right. Let's see. I guess at this point, I don't know much more to show. Oh yeah, let's do a live demo, right? Now let me do a refresh here, and let's prove this stuff works. So let's go from host 1. Let's go ahead and ping host 3. So from here to there, this is a demo. So I'm gonna go here, get to the console of it, right? Console, yeah. And I'll log in here. Servers, and IP address, right? And if I do a ping, .0, well, I was gonna ping 20.0.0.2, right? And there we go. So answer from our rules, and now we're doing forwarding, through rules from this subnet to the other. Just so you can see, if I do a cat proc net ARP here, you see we don't really have an ARP for anything outside subnet. And sure enough, 9F02 better be the MAC address of the IP interface on our node here. So we can just scroll up real quick here, and sure enough, it is. See that? Right? Go back here, 9F02, 9F02. So that's how, when we route, we can go from and to that MAC address. And I think I'm way past my allocated time to be talking about this. So I will post the links, and I'll have it together with this file so you can look at that. And I'll thank you very much for your time. All right. Okay. See ya.